We are learning today about cross-curricular issues associated with maths and science within the primary school. For many years there has been much debate in regards to different approaches to teaching, in particular the cross-curricular approach. Thus, this presentation aims to discuss some of the organisational issues and pedagogical decisions which are often associated with cross-curricular practice. Furthermore, I will also explore and give evidence of how ICT tools can be used within the classroom to aid cross-curricular learning, particularly within science and mathematics. Although cross-curricular teaching can be implemented throughout the whole school, this presentation will solely focus on children aged between 5 to 11 years old. So, how can we define cross-curricular learning? Well, Penny 2011 argues cross-curricular teaching cannot be formally defined to one definition, as different schools, organisations and practitioners may hold different beliefs on what they believe to be a true representation of cross-curricular teaching. However, despite many individuals possessing their own views as to define the approach, there appears to be a shared worldwide perception of cross-curricular teaching which helps form the basis of these definitions. Jacobs 1989 and Hayes 2010 both share a common understanding of cross-curricular teaching. They both believe one is adopting a cross-curricular approach within the classroom when different subjects are taught side by side in relation to a similar topic, theme, issue or project. However, one can argue such definitions do not accurately define cross-curricular teaching. Is simply teaching a combination of subjects together a true representation of the cross-curricular approach? Alternatively, Barnes 2011 suggests demonstrating a cross-curricular approach refers to skills, knowledge and attitudes of a number of different disciplines having to be applied to an experience, theme, question, problem or idea. This definition, given by Barnes 2011, seems to demonstrate a deeper understanding of the cross-curricular approach. This definition suggests cross-curricular teaching is far more complex than simply combining individual subjects. Instead, it comments upon the need of many different aspects being present before being classified as a cross-curricular approach. Where did cross-curricular practice originate from? There are three key reports which are often associated with cross-curricular teaching and learning. First of all is the Haydow report published in 1923, which actively encourages adopting a cross-curricular approach. The report suggests delivering lessons in the form of project or topic work, rather than dividing the curriculum into individual subjects. Following on from this report, the Plowden Report 1967 comments upon using cross-curricular teaching within the primary school environment. Lady Plowden declares children's knowledge cannot be divided into separate compartments. Furthermore, the report states effective problem solving can only take place when children are given the opportunity to create links between their existing knowledge, interests, new ideas and concepts. Last but not least, a more recent Rose review published by Jim Rose in 2009. Within the report, Rose claimed high standards are best attained through the use of cross-curricular learning within schools, as it allows children the opportunity to apply their subject knowledge in different contexts. Is adopting a cross-curricular approach beneficial to children's learning? Needless to say, all teaching approaches have their pros and cons. Cross-curricular teaching is no exception to this matter. It would seem the need for cross-curricular links between subjects are highly emphasised within the current 2014 national curriculum. However, before exploring methods of implementing this approach, it is vital we recognise the advantages and disadvantages associated with cross-curricular teaching. Byron and Brody 2012 explain how a cross-curricular approach can provide a richer experience for children's learning. They believe through cross-curricular teaching, children are given the opportunity to gain a deeper understanding through exploration of different contexts. This can prove to be a beneficial tool within schools, as some children need to explore aspects of a topic using multiple strategies to truly gain an in-depth understanding of that topic. Similarly, Barnes 2007 states a cross-curricular approach can demonstrate a positive impact on children, particularly their motivation and engagement within lessons, and ultimately affect their academic success. Personal experience has demonstrated a cross-curricular approach in the form of topic work allows teachers to implement creative lesson plans whilst achieving targets within individual subjects, although it can be hard to assess children due to success criteria linking to multiple subjects. Moreover, it is important to remember all children learn differently. Thus, trying to strengthen a child's understanding of a topic within multiple contexts may in fact hinder a child's understanding and progress if links are not strong enough. Furthermore, Moyes and Reynolds 2013 argue the cross-curricular approach does not allow children to become competent in subject-specific skills. Similarly, Owen and Ryan 2001 state the cross-curriculum approach has been criticised for not allowing teachers to plan for pupil progression. They also discuss the possibility of individual subjects losing their identity underneath a blanket of topic work. During classroom experience, I have witnessed a few occasions where students cannot identify individual subjects which have been combined to form a lesson. This may suggest children are failing to identify different aspects of individual subjects, which may cause confusion when children arrive at secondary school, as they may not understand the values of individual subjects. Should maths and science be taught together? Within the current 2014 national curriculum, there are many noticeable links made between mathematics and science. Additionally, the new curriculum states children should be able to apply their mathematical knowledge to science and other subjects, thus emphasising the need to incorporate aspects of a cross-curricular approach within the primary school classroom. Furthermore, Penny 2011 declares links between mathematics and science will always exist and are sometimes inevitable. This reinforces the notion of both subjects being very interlinked. Mathematics will always provide a context for multiple areas in science. It also allows children to further develop their mathematical skills through application in certain areas of science. Within the new curriculum, the mathematics statistics framework suggests children need to be able to interpret and display data in a variety of different ways and contexts. This can directly correlate to the curriculum framework for working scientifically, which incorporates skills such as counting, classifying, pattern seeking, measuring, drawing graphs, and estimating. During my school-based training in Year 4, I was fortunate enough to be given the opportunity to interlink both my maths and science lessons. During one of our science lessons, we were investigating how temperature changed over time. Children were asked to carry out an investigation which required them to record and measure temperatures. They also drew a frequency table in their books. Straight away, children were incorporating fundamental mathematical skills such as measuring and recording data within their science lessons. Additionally, that week we were looking at different graphs in our maths topic. So children used the data from their investigation in science to draw bar graphs in their next maths session. Thus, children were allowed the opportunity to interlink knowledge gained in both sessions to produce work which featured elements relating to both topics. How can ICT help support cross-curricular learning? In today's society, the use of technology, particularly ICT, is becoming a fundamental aspect of everyday life. The use of ICT is being emphasised within the classroom through numerous ways such as interactive whiteboards, iPads and Fizzbooks. Feasy and Still cited Hayes and Whitebread 2006 say teachers should be prepared to offer children the opportunity to incorporate ICT within their lessons to ensure lessons are engaging to pupils. Furthermore, Ward et al. 2008 argue, if used correctly, ICT can support learning in maths and science whilst providing a valuable learning experience. ICT can be used in multiple ways to help support maths and science. Let's refer to the example on our last slide, in which children carried out an investigation on temperature during a science lesson whilst incorporating multiple mathematical skills. Instead of asking the children to draw the bar graphs in the following maths session, I could have booked out the iPads if available and incorporated ICT into my lesson. Children could have used the iPads or Fizzbooks to create a spreadsheet on Microsoft Excel, displaying their investigation results, then use those results to create a series of graphs within Excel. Additionally, children could have used electronic devices such as data loggers to accurately record information including measurements when exploring data handling. To conclude, it is evident implementing a cross-curricular approach has many beneficial aspects, particularly when combining mathematics and science, which can be further supported through the use of ICT. To teach mathematics without science links being present and vice versa is inevitable, and through adopting a cross-curricular approach, no doubt, children are given the opportunity to enhance skills in both subjects. However, school-based training has shown me Cross-curricular approaches may not work for all subjects, particularly subjects such as geography, music, art and history, as some strong links cannot be made between subjects. Furthermore, I believe the cross-curricular approach in some aspects can hinder a child's progress due to children being allocated into an ability group. When planning lessons, do you follow a plan for writing ability or allow children to be mixed ability groups? As a teacher, cannot predict if a child who may not do so well in literacy may not do so well in other subjects such as art and geography. Lastly, I believe teachers should incorporate ICT within appropriate lessons, regardless of their own ICT ability, as we now live in a society where children are often introduced to ICT before starting school, so we must positively embrace this feature within the classroom.